Hi everyone, I'm Stephen Downs. Welcome to another video in the series for Ethics, Analytics, and the Duty of Care. Module 2. This video will cover the topic of prescriptive analytics. And before we get going, I'm going to copy the video URL into the Activity Center video so that people can watch it as I broadcast it, as I create it. Unfortunately, there's no way to know the URL of the video that I'm creating before I actually create it. A little predictive AI would be helpful here, wouldn't it? So I've just got those in there, and now I'm going to click, not delete, page publish, and that'll get it in there for me. And I'm just going to turn on the recorder here so that I don't need to worry about translating or transcribing on the fly. So this is, again, the presentation on Prescriptive Analytics, Module 2, Ethics, Analytics, and the Duty of Care. And I am, of course, Stephen Downs. And thank you for joining me. If you're watching, you're probably not on YouTube right now. I don't see any viewers. Or if you're watching the recording that comes later. So I'm just going to set up these slides. These slides will be up and running here in just a second. So, and again, I have to set up the slideshow because Microsoft always resets it to present full screen, but I've done that now. So I'm going to start, and there we are, Prescriptive Analytics. So the topic of prescriptive analytics essentially is a branch of artificial intelligence and analytics that makes recommendations for me. It'll say, we have an example here of marketing analytics, work this deal, not that one, sell this product, not that product, do this task, not that task, etc. And we can see how this is going to have some obvious applications in teaching and learning, both from the perspective of the teacher, making suggestions about what to do next in a classroom, for example, and from the perspective of a learner, what to study, how to study, where to study it, when to study it. So, as with previous discussions of applications or uses of analytics, I'm breaking this down into a number of different topic areas or categories, as I'm calling them. This breakdown is purely arbitrary, and of course, we could think of many other ways of dividing up different applications of learning analytics, but that's what I've chosen for this point. So the first and foremost of these, and of course you had to be expecting it, is learning recommendations. And this breaks down into two major categories of prescriptive analytics. On the one hand, we have content recommendation systems. Now, content recommendation goes back several decades, and there have been a variety of different approaches to content recommendations over the years. These days, it's based on collaborative filtering and other AI metrics that identify what people like you, who are in your program, who have similar aptitudes, maybe similar learning styles, any range of properties, what they have done well with, then the system recommends a similar sort of thing for you. A more difficult challenge, but one that has been of interest in the AI and analytics community for some years, is learning path recommendations. Here, we're not just recommending learning resources on a case-by-case, item-by-item basis, but rather we're recommending a path through a variety of different alternative resources or even topics for learning in order to reach a learning outcome or a learning goal. So these kind of recommendations may even select courses or lessons or topics. It may simply outline a learning path, or it may offer personalization parameters. Again, it may be based on learning style, it may be based on mastery learning, maybe even on things like time limitations or knowledge background. They're used by course generators, course or learning object sequencing systems, and they can be used for both online and offline education. The second major category, and this is related to the first, is adaptive learning. These are AI systems that look at how a person is performing in the context of a course or a learning environment and adapts the system to that. We see this more in games, actually, than we do in educational applications. A gaming engine will track a person's progress closely and adapt the presentation of challenges, enemies, whatever, to the person in order to challenge them, but not too much. Similarly, with adaptive learning, you're trying to challenge, but not too much, the individual learner. You want them to push themselves in order to succeed, but you want not to push them so hard that they give up. So you have to have an artificial intelligence that monitors what the student is doing and then adjusts the difficulty of the content accordingly. Another class of prescriptive analytics is especially useful in large open online courses, and that's adaptive group formation. In many educational scenarios, the use of small groups is encouraged in order to enable each person to take part in the discussion, to engage in small group dynamics, conversation, feeling more like they're participating and contributing to the course rather than simply receiving content. This is not something you can do with a single group of 1,000 people or more, so you need to break down your course into small groups. This, however, can be difficult. People who know each other may cluster into groups, but you're going to have, especially online, a lot of outliers. As well, people will be participating to different degrees. You'll have people who are very engaged and active, and other people who are more lurkers, or as we call them, legitimate peripheral participants. Indeed, in your group, you may have people dropping out of the course partway through. And so there's the risk of a scenario where a person is the only active member left in their group. So there's a need to have adaptive group formation that takes into account all of these and additional variables, and to manage the group formation as the course continues in order to ensure that people have a useful and productive small group experience. Related to this, and similar to this in many respects, is placement matching. This would be used by systems or applications that are looking to provide real-world experience. For example, an educational program looking at co-op placement may use an AI system in order to match potential students, potential co-op employees, in other words, with potential employers. There's another case in the Government of Canada where the Treasury Board of Canada piloted a project with us called Micro Missions, where government employees would be considered for short-term assignments in other departments, just to broaden their experience and help them learn new skills. And an AI was used to match these potential short-term placement people with the short-term placement opportunities. Any place where you need to match a person with a resource or a person with an opportunity, you're going to have the need for an opportunity to use artificial intelligence and analytics to make this more effective and especially a lot more efficient. And that brings us naturally to the topic of hiring. I've been involved in a number of AI for hiring or AI for job interview projects over the last few years. Right now, we're seeing corporations already using artificial intelligence and automation in order to push the hiring process. I haven't seen a case where an AI has out and out hired a person yet. Typically what happens is that these systems work hand in hand with human recruiters, making suggestions, creating the short lists, matching a pool of candidates to a specific job profile or opportunity. That said, these systems can do everything from phone interviews, posting ads, screening resumes, even pre-screening candidates, so that when the human actually gets into the loop, they're looking at much less time and resources in order to accomplish their hiring goal. Similarly, artificial intelligence or analytics can be used to make pricing decisions. We're seeing that a lot already in other industries. For example, in airlines, AI-supported applications help with what is called differential pricing, where the system calculates how much a person would be willing to pay for an airline ticket based on their background, the time they're purchasing the ticket, other factors, how frequently they fly, whether they've purchased business class tickets in the past, etc., and then makes the offer accordingly. Companies like Uber adjust their pricing according to demand. We've all heard of Uber's famous or perhaps infamous surge pricing, where as demand rises, so does the price. And this is calculated not by a person sitting in a room, but by a fairly sophisticated analytics engine. The same sort of thing can be done in a learning environment, both for the pricing of tuition or other fees for access to learning, as well as the pricing of resources such as books and applications, notes, and other sorts of support. Probably, and I don't have direct evidence, but probably this is already happening in the publishing industry. There have been examples where companies that publish online newspapers or magazines or journals have been using AI to determine whether or not to put up a paywall blocking access to a resource based on whether that AI thinks that a person would be willing to pay for the resource, as opposed to, say, somebody who's just casually browsing. As a result, I get a lot of these paywalls, but I'm still not willing to pay for them. This feeds into a general set of applications around decision making generally. AIs can support decision making at pretty much any step of the process. Typically, AI will be used to handle the comprehension of big data, which is what we saw in things like descriptive analytics and even diagnostic analytics, basically setting the stage for a person to make a decision. The AI can also map out the set of possible actions for the actual decision maker to consider. This person now will take into account other information that the AI might not have access to and then actually make the decision. Although we can imagine, can't we, a scenario where there is no other information available, and so the AI that is making the suggestions about possible actions may be actually in the best position to make the business decision. So those are overall some applications that constitute the area of prescriptive analytics. Perhaps you can think of more cases or more types of cases where an artificial intelligence engine or an analytics engine can make a recommendation or make a suggestion to you. Certainly there are many cases in learning and development where these tools can be applied. If you do find such a case, then I recommend you go to the list of all applications in Module 2 of the course and submit them as your own suggestions, and that way we can get as comprehensive a list as possible for the different prescriptive applications of AI and analytics. So that's it for this video. The next video in this series will be a look at some applications that are generative in nature, that is, applications that we use in order to create things. If you're watching live, and you might be, I'm going to be doing that right away. So give me about 2 minutes, then reload the Activity Center website. Otherwise, if you're not watching me live, look for the next video in the Ethics, Analytics, and Duty of Care playlist, or if you're listening to this as a podcast, this will be the next item in the podcast. So that's it for now. I'm Stephen Downs. See you shortly.